Okay, so welcome to week 4, day 2 of the Delta Platoon. Tonight we're going to be talking about regular expressions. Um, and I think a popular quote that goes around on the internet from a programmer is some people, when confronted with a problem, think, I know, I'll use regular expressions. Now they have two problems. So that quote was more in reference to the programming language Perl, where regular expressions are a tool that can be used for almost everything and not a critique of regular expressions in general. So it was more a comment on how Perl programmers try to use regular expressions for everything. It's like the old adage, if the only tool you have is a hammer, then everything is a nail. So regular expressions, very, very powerful tool for um, pattern matching. So let's go ahead and see where we are. And we'll go ahead and we'll make a directory for project test, cd project test, and we'll make a Python file called regular expression. And that's good. Okay, so in order to use regular expressions in Python, this step one is we have to import the regular expression library. It's just import RE. And that's basically it. So you can start simple. So let's say we just want to match a string. So we'll just say our regular expression equals R. So who's seen the R prefix before a string before? So basically, you've seen F strings, right? Where you can substitute values for expressions in strings. So like if I have my string equals F, value is a value, and I say my value is 2, and then I print my string, right? It's going to substitute the value for the value in there. So if I open up my terminal and run this, right? Don't need you debug console. CP. So if I run this file, what should the value that's printed out be? What should it say?
2 is a value.
Yep. So we should just have 2 as a value. And if I put in like a /n and /t, what should it look like now?
It'll tab the 2, and then after the 2, it'll be a new line for is a value.
Yep. So it tab spaces the 2 and it adds a new line because basically it sees this /n and interprets that special character as a new line. So any idea what's going to happen if I turn this F into an R?
It won't do that. It'll just print the /t's and /n.
Yep. So yeah, so these, it ignores these as special characters and just interprets them as regular characters. It doesn't substitute any values, and it doesn't, again, it doesn't interpret these special characters. So R strings are what we use when, or raw strings more generally that are prefixed with an R are what we use when we're defining regular expressions. So let's say I have a regular expression string, and then I have my string equals string, string, string. And I want to know, excuse me, man. I want to know, I want to find the first occurrence of string in string. So I've got this RE, which is the library imported for regular expressions, the search function. You can see from the function definition, so it takes a pattern, which is our regular expression, or a list of patterns, and it takes a string and then some optional flags and other arguments. But basically, what string does is it looks for a pattern to match, and if it finds it, it returns a match object. If it doesn't find it, it returns none. So if I pass in, excuse me, I'm going to pass in a regular expression first, and I'm going to pass in string, or sorry, my string. And we've got this match object, which tells us that it found our string and the match was string. And if we change this to like ing, it should find it again, and it should be the first occurrence. If we want to find, sorry, if we want to find all of the occurrences of it, we do a regular expression dot find all. And see, it returns a list of the 3 occurrences of ing that are in this 1, 2, 3. So match, or sorry, search tells you if the regular expression is found in the string. Find all finds all occurrences of the regular expression in the string. And then another function that's commonly used with regular expressions is match. So, and it takes the same arguments. It's going to take our regular expression and our string. And what match does is it's going to find the first occurrence of our regular expression in our string. So find all will find all occurrences. Match finds the first occurrence. Oh, my string, not string. So, and it found none. So why is that? It's because match only searches the start of the string. So if we were to change this, so because it starts with an S and the first letter of our regular expression is an I, it's not going to find anything. If we change this to string, then it's going to find it. See, it found first match and a match of first objects. So these are your big 3 functions that you're going to use with regular expressions. So search searches the whole string. Find all will find all occurrences. A search will search the whole string and tell you if it finds whatever pattern is in your regular expression in your string. Find all will find all occurrences of your regular expression in your string, and match will match the start of the string with your regular expression. And if it finds your regular expression at the start of the string, it will return that there's a match. Any questions about those 3 functions?
Yeah, so for match, does it have to be exact? I know you said it starts at the beginning, but what if you have like str as your regular expression on 3?
Yeah.
Will it still come back because it matches the first 3 letters?
It has to match the whole pattern. So what were you saying?
Oh, it has to be exact. Okay.
Yeah.
Well, no. I was just curious if you could just have like a few of the letters as long as they started.
So not when you're using, so there is a way to do that, which we'll get into with regular expressions, where you can match certain characters and not other characters. But for a plain text string like this, you've got to match the whole plain text string. But the gist of it is you have to match the whole regular expression. So when it comes to regular expressions, so the example we were looking at here is just ordinary characters. So like lowercase a to z, a dot dot or uppercase A to Z, Z 0 to 9. If you put ordinary characters in your regular expressions, the regular expression is it's just going to match them exactly, right? There are certain characters which are considered special characters and have special meanings for regular expressions, which we'll talk about a little more, but you have like the caret, you have dot, you have $, star, plus, you got the brackets, parentheses, you got slash, you got or, and you got the group symbol. So all of these match exactly. These are special characters, which are interpreted by the RE library. So these mean something else, basically. You can't use these, like if your string had a character, like you wanted to search a string that looks like this, you can't do this without escaping it first, which is done using the backspace character. But this is not going to work if you just want to match on plain text, because this means something else, which we'll get into in a minute. So the first special character I want to talk about is the period. So a period, you can use a period in your regular expression to match any character except the new line character, which is the /n. So what does that mean? So let's say my regular expression equals an R string, and I want str dot ng. And then my new string equals, so I got string, strong string. So if I do a find all on this, sorry, excuse me, re dot find all, and then I want my re and so what do we think this is going to find? How many occurrences, and what are they?
The last two, strong
Yeah,
and
the last two. So it'll find anything. How about this? Is it going to find that? Will it find this last character?
yeah. How
The
many
answer,
there? 1, 2, 3,
the
4.
answer is actually no, because this is only going to match one character. There are ways to say, hey, look for multiple varied characters, but this dot should just match one character in this regular expression. So if I do a find all on this, it should find strung and string, but not however you put the first and fourth characters. What did I do? Oh. Did I put them in? Go, I did it. My string is wrong.
I was gonna say maybe that variable being called RE is doing
Yeah.
something weird.
It should work. We could try something different.
Can you add many dots for each?
Yep, you can have as many dots as you want, but there are ways to say that you want, like, and we'll get into them, like I want 0 or 1 characters, I want 0 or more characters, I want more than 0 characters. That's how some of these other special characters come into play. So what did I do here? Let's try this. What did my error message say? String object has no attribute find all. Okay. Yeah, it was the RE was the issue. So because RE is the name of the library, it's looking at RE as a different kind of object that I can't use it as. So you all were right. So it finds the strung and the string. If I were to put one more dot in, now it's looking for two special characters in the middle here, so it should find this last one. Yep, which it does, and I could do that, any number of times. So that's the gist. So dot, it matches any character except the new line. So if I were to do something like this, it should just find strong because it's not going to match this new line character in the middle here. Any questions about the dot operator? So the next special characters I want to talk about is /W. So /W will match any letter, digit, or underscore. So I can use it in the place of any letter, digit, or underscore. So let's say what do we want to look for? So let's say we /W. So I want to look for anything, any one letter, digit, or underscore followed by foo. So my new string 3 equals foo 1 foo 4 underscore foo or a foo or b foo. So what do we think this is going to match here? If I run find all on this.
One foo, under foo, a foo, underscore foo, a foo.
And it's actually going to match this too, because it doesn't care that there's an A in front of it. It just sees, it just sees the B foo. So it should match 1, 2, 3, 4 and drop the A. Because it's not looking for white space in between them. It's just looking for the pattern, right? So if I were to do something like C foo, it should find A foo, C foo, and B foo. But so let's see. So you can see it finds all of them because it doesn't care about the white space. We haven't told it to look for white space. So it's just looking for patterns. So if I were to remove all the white space here, it should find exactly the same thing. And it does. So it's just think of it. It's just a computer. It's doing exactly what we tell it. And the pattern we're trying to match it is any letter, digit, or underscore followed by a foo. If we were to do this, now it's going to look for 2 of any letter, digit, or underscore followed by a foo. So it should just match this because now it cares about the white space because this is not a letter, digit, or underscore in any of these. So it should just find this AB foo, which you can see it does. So, and then the corollary to W is capital W. So a good rule of thumb for these special characters here, like, so this finds any letter, digit, or underscore. This finds not any letter, digit, or underscore. So it's basically the opposite of this. Is what happens when you have the capital W. And then if we want to match a white space character, we have the /S, which is any white space character. We also have, if we want to match tab, new line, or return in that order with tab, new line, and return, we can match those. And then kind of similar to this lowercase w, we have a lowercase d, which matches, excuse me, matches any decimal digit. So anything between 0 and 9. So one thing to consider here is this right here equals the regular expression. We could say a to z, 0 to 9, and underscore. These are the same thing. So if you put something in brackets, that's going to pattern match one character. If the character matches anything in the brackets, then it matches. So this is equivalent to this. And this, so this would be equivalent to 0 to 9, or it might be ... 9. So those should be the same. If I want to match something in the start of the string, I can use the caret. So that tells you to match, match the start of the string. And you might be thinking, why does that matter if we have the match function? But if you have a multi-line string, the caret is going to match potentially at the start of each line. So if I have something, let's say, I want to match an A, B, or C at the start of the line, followed by a, T, or just a B or C. And then my cats, let's just white space. So I'm going to print this, find all. So this, let's see, why isn't it breaking over lines? Okay, so I was wrong about this. This is only going to find the start of the string itself. And then if I want to match the end of the string, the $, match the end of the string. So I could so this should match sat. Or sorry. Am I doing wrong? It's been too long since I looked at this. Let me go back to the documentation. So maybe I'm misunderstanding how the matches the end of the string or just before the new line at the end of the string, and multi-line also matches before a new line. Oh, so you have to put it in multi-line mode as the flag is what I was doing wrong. So if I were to do, so what if I was doing here, I were to go in and say multi-line, then it should match more than I was telling it to. Yeah, see, now it finds the cat in the back because it's looking on multiple lines. Otherwise, it's just looking at the strict start of the screen. So this, I was talking the optional flags. Flags. So there's this multi-line which tells it to look at the start of each line for the pattern because we tell it to the start of the string. And it should be the same with this. Let's see. Nope. Anyway, I'll have to take this as a lookup and I'll get a better answer for you for how that character works.
Does the dollar sign have to go at the end of sat?
I think yeah, that sounds right. You are right. Let's look at the documentation again. Yeah. Yep. So if you look in documentation, was that Nicholas who said that?
Yes, sir.
Yeah, thanks. You are 100% correct. The dollar sign has to go at the end. So it should find it now. Yep. So before it was just looking for nothing since the dollar sign was at the beginning. Okay. Couple other ones. So we talked about square brackets. They just compose like a set of characters that I want to match. You also have this if you want to escape a character, so inhibit the special. So if I want to match a period, I would do that to inhibit the specialness of it. So to match a period inhibits the specialness, I guess. The dot. But you can use that on any special character, any of these special characters from the beginning. If you want to search for parentheses or brackets or slashes, you have to use the slash to inhibit the specialness of it. We talked about the caret. So if I want to match 0 or more, excuse me, I think it's 0 or more occurrences of the pattern to the left of the star. So this star operator will look for 0 or more occurrences of a pattern. So what does that mean? Oh, excuse me. So let's say my regex is, say I want to find A. And then string. So this should find the A, the double A, the triple A, and the A repeated 4 times. To the left, sorry, to the left, not to the right.
You got to print it, right?
I do have to print it. I am on fire tonight. See, this is why coding in public is a lot of fun, because it's where, yep. What did I do? Doing well. Yeah, so this matches 0 or more occurrences of A. So it's going to find when there's no A, and when there's A. So that's probably a bad example. There's a better way to do this though. And that better way is plus symbol. Matches 1 or more occurrences of the pattern. This is probably a better example of what I was trying to do. Let's clear the evidence of my shame with the error message. And try this again. Yep, so now it finds all the occurrences of 1 or more A's. And then the last symbol that does something similar is the question mark. So, and that matches 0 or 1 occurrences of the pattern to the left. Okay. So any questions so far about the regular expression functions or the different special characters and what they do?
It looks like the find all function always returns a list.
Yeah, it's always,
Always the case,
if it doesn't find anything, it's the empty list. Otherwise, it's a list of all the matches that it finds.
but it only searches a string. This is also for strings, the rejects. They're all searching a string.
Right,
Yeah.
right. It's always a string. Okay, so let's work together and try and develop a simple email matching regular expression. So what's the general format of an email?
You've got the the CC, the subject, and then the body.
No, just
and then the
sorry,
signature at the end.
email address. I steered you wrong, James. Email address.
Yes, an @ sign.
Yep, so there's an @ sign typically in the middle, and then what's on either side of the @ sign?
.com or the dot something.
At the end, there's a .com. And then what about between those? Let's just keep it simple, and we'll say that an email can be any number of letters, numbers, and underscores, followed by the @ symbol, and any number of letters, numbers, and underscores. Okay, so that makes sense. So before that, we can have any number of letters, numbers, and underscores. After the @ we can have any number of letters, numbers, and underscores. So who wants to give a shot at what that's going to look like as a regular expression? Sorry, I should say I should say 1 or more, not any number, because you can't have an empty email address. So what do we think this is going to start with? Which one of our special cases? Well, looks really similar to this backslash.
A slash W. At the
Yep,
very least.
/W.
Yeah.
And then what? So this will match 1 of any letter, number, underscore, but we want to match 1 or more. So what should we follow it up with?
plus.
Plus.
Plus, yep, a plus, so this will match one or more, and then what comes next?
You could put like square brackets in the at symbol or
I think we
Three.
can just use the at symbol, and at
Okay.
symbol's not one of our special characters, so it's just gonna match it exactly.
okay.
I think so. And then what should the end look like after the at symbol? Should be the same as before, right? Because it's just the same pattern. One or more letters, numbers, and underscores. So this is a simple email regular expression. So if we have a string of emails and we say john@john.com, and then we have J27 at J27.com, and we have J54 $sign at J, and then string of, we'll just call this a string of stuff because they're not all going to be emails. String of things. And then we have hello 123 Main Street. Okay, so this should find this john@john.com, J27@J27.com. It should not match this because of the $sign, and it shouldn't match this because they're not even close to matching the pattern. Does everyone agree with that?
We don't have to account for the dot.
We
com.
can. I simplified it. So we
Okay.
can, and we'll take a look at that in a second. But if you want to, you're saying like account for the .com. This should match it, I think. I think that I oversimplified my definition of /W, but we'll see. Yeah, I think that I oversimplified it. So let's see. We might have to account for the dot. And what do I do? I need to print. I need to. So you can see I didn't give it any arguments. So it printed my function. It took in a function type and spit it back out and didn't evaluate anything. So let's see what happens. Yep. So, but you're right. It doesn't match the .com. So we need to add. So how would we account for the dot?
Don't we
So
have
let's
to
have-
use the backslash to consider the period and not the special dot?
Okay, so here's my updated definition. So I want to follow that by a dot. So I want to follow my second one or more numbers of letters underscores followed by a dot and exactly 3 lowercase letters. Does the new definition make sense? So I'm going to put a slash and a dot, which let's just check and make sure that finds the dot and works. And it does. So now we can find our dot because we escaped it. Now, how am I going to find exactly 3 lowercase letters?
3 /Ws.
Yep, that is. So is that going to find only lowercase letters though?
No, yeah, nope.
Yeah, so that'll find uppercase letters. So I don't know if this is true, like a true definition of how emails are written, but let's just say for the sake of this, we want to find exactly 3 lowercase letters. So if you remember up here, we looked at, and we didn't really delve into it, but the brackets. So if I want to just look for A to Z, any character between A and Z, I can do something like this. So this will look for it once. This will look for it twice. And this will look for it a third. That should look for it a third time. And I think that should work. There's probably a simpler way to do it, but I think this should work. Yep. You can see that it does. So then if we add like a 4th letter, it shouldn't match that. Nope. Okay, so that's a really simplistic pattern for matching emails. How about phone numbers? I know this is one of the challenges for tonight, but let's say we want a regular expression to validate a phone number. So what are some of the different ways that phone numbers can be formatted? Like how could you write a phone number? I could just say 1, 2, 3, 4, 5. Not enough digits. Nope, one more digit. Right? So we got area code, 3 digits, and then 4 digits. That's one way, right? You could just write the numbers. You could say or I could say 1, 2, 3, 6. Let's just say, for the sake of simplicity, these are the 3 expected formats that are allowed for phone numbers. But we want to come up with a regular expression to validate whether something is a phone number or not. So how are we going to do that? So what do we have to look for first?
The digits of /d.
Well, we got
Oh,
this.
well, no, actually.
We got this parentheses though, right? So how are we going to look for that? So we got to say, is there 0 or 1 parentheses? Right? So that should look for an optional parentheses, and then we want to look for the numbers between 0 and 9 3 times. Is that right?
Yeah, so just /d.
Yep.
3 times over.
Yep. And then what's next? We could have another parentheses. We could have, or we could have a dash, both of which are optional. So the other closing parentheses is going to be just like that. And then we could just do, I think we want to do this as a grouping. So we can say either the closing parentheses or a dash. I don't think we need to escape a dash. So what this is doing is saying you can have 0 or 1 of these characters. Or we could say this like, but I think this will allow you to have a phone number with this also, but that's fine. And then 3 more digits. And then what's next? Another optional dash, and then 4 digits. So does it seem kind of repetitive that we have to put 3 of these and 3 of these and 4 of these? So that kind of violates the do not repeat yourself principle. So there's actually a way to say, hey, look for 3 digits. And that way is using square brackets. So this is going to say, I want exactly 3 digits. I want exactly 3 of whatever's to the left. I want exactly 3 of whatever's to the left. And I want exactly 4 of whatever's to the left. So the square brackets tell it, I want this number of whatever this is to the left. So let's try some phone numbers. So this should find it, right? This should verify that this is a So we got 3, 6, 9. So this should verify, this should find this phone number. Does everyone agree with that based on our regular expression? What did I do? Oh, I know what I did. Oh, what did I do? Oh, my question mark's on the wrong side here. Mark is also on the wrong side. I think I would have learned my lesson earlier, putting things in the incorrect position. I did not. So you see it finds 77786. So why is it splitting them up into 3 different strings?
I think it's because the parentheses form the groups.
They do, but this should be one group. And then this should be escaped. This should be escaped. This is another group. This matches only with that. Maybe I need to do. Remember how I was talking about how you can quickly get into trouble writing regular expressions for things? Does everybody believe me now? And I even practiced this before. Anyway, let me look at this a little over the break. And I'll talk about it some more.